Hello and welcome back. In this module, we will consider the second case where the denominator can be expressed as a product of repeated linear factors. But before, let's recall that when we get a rational function, the degree of the numerator must be less than the degree of the denominator, and the denominator must be factorized. So consider an example where we have repeated linear factors, as in this case 3 times. Then we can express this rational function as a partial fractions, like this a over x plus b over x minus 1 plus c x minus 1 squared plus d over x minus 1 power 3. Okay, now we want to determine the coefficients a, b, and c, and d. And this can be done by making or having a common denominator. Then we can compare the left side with the right side. Now for this situation, we're still missing x minus 1 power 3. So we can multiply x minus 1 power 3 up and down. For b, we have x minus 1, we're still missing x and x minus 1 power 2. For c, we are missing x and x minus 1. For d, we only need x. If you do not remember how to reduce, to expand x minus 1 power 3, just use the fact that x minus 1 power 3 is x minus 1 squared, and then expand x minus 1 power 2 into x squared minus 2x plus 1. And then you can multiply the first one with the second, with the first one, the second one, and so on. Okay, minus 2x squared minus x squared, it is minus 3x squared. Minus 1, the same as this. X minus 1 squared is equal to x squared minus 2x plus 1. Then we can multiply x by x squared, which return an x cubed. Now we get the common denominator, x multiplied by x minus 1 cubed in both sides, so we can compare the left side to the right side. So this is, you can consider at 0 multiplied by x power 3, right? So 0 is equal to a plus b. Okay, x squared, the coefficient of x squared is equal to 1. So 1 equal to, the coefficient of x squared is minus 3a minus 2b plus c. The coefficient of x, there is no x, so the coefficient of x is 0. Okay, the coefficient of x is 3a plus minus c plus d. The coefficient of x is minus c and plus d, and the remaining part is 1 from the left side, which is equal to minus a. So there is no x for b, so there is no remaining part on b and c and d. So minus a is equal to 1, so a is equal to minus 1. Substitute a by minus 1, you can get b equal to plus 1. Now you can get c, substitute a by minus 1, you have a 3a, okay, and substitute b by 1, you have minus 2, and if you get this term, you get 1 and 1 on the side, then c is equal to 0. Okay, substitute c by 0, minus 3 plus 1 is minus 2, then d is equal to plus 2. That's good. Okay, so we substituted a by minus 1, b by 1, c is equal to 0, so we eliminated this part, and d is equal to 2. Now we are asked to integrate this rational function by dx. So for sure we integrate this side. It's easier. And this is equal to minus ln x plus ln x minus 1. Okay, so the integral of 2 over x minus 1 cube, if you do not know the formula, just use the substitution formula. Okay, integration by let u equal to x minus 1, then du by dx is equal to 1, du equal dx. Du. The integral of the constant can be taken outside. The integral of u power 3, we can get it up, which is equal to minus 3 du, right? Then the integral simply is we add 1 and divide by the minus 3 plus 1. Okay? Two can cancel 2, okay, and get 1 minus u squared plus c, which is equal to minus 1. We substitute u with the x minus 1. Right, and that's it. So in case you have a repeated factor in the denominator, just use the partial fraction decomposition in the following form, and then you should determine a1, a2 till ak, and then those can be determined by elimination or by calculator, okay, as we did, and then you can perform the integration of the rational function on the partial fraction. Okay, so now take the chance to solve those exercises by yourself, and you can find the solution below the video. Good luck.